In this video, we're going to investigate the graphs of the derivatives of functions, and we're going to do one function in particular here. And so in a new Geogebra window, which should look like this, go to the input box, if you want to do this with me, and enter f of x equals, and we're going to do x cubed, so x, and then to do the cubing, you head over here to the alpha key, which gives you all these options. We're going to just choose that. X cubed, we're going to do minus 12x plus 4. I'm going to hit return, and it's going to pop the graph up there. Mine came up in green. Well, I'll go change it to the same color in a little bit. So what I don't like about the graph is that, first of all, it's off center. So I'm going to move it over. A lot of times you can just use that pointer tool, grab it, and move it on over. Another option sometimes is to go to this icon at the top and hit Move Graphics View, and that allows you to control and move it around as well. So now you'll see I can even mess with it like that. But what I'd like to do is go make these axes so that the y-axis isn't so elongated. So if I hit Control, click on the axes, you'll notice I get this little menu right here. And what I want to do is go do a ratio for the x to y-axis. And I want to take that y-axis and have it go 10, 20, 30, 40. So I'm going to do a 1 to 10. And that'll shrink it down. And even if you want to get a better view too, if you click on the center here, if you go to zoom in, you can even go right to the center and you can get a really nice view of this graph. I'm going to do it twice. I like this view. Actually, I think I'll even zoom out once here too. Just get it nice and perfect. Click in the center, and it's exactly how I want it. So the next thing I'm going to do, I'm going to go grab my pointer tool. I'm going to go change the color of this. And to do that, I just, again, control click on it. And I'm going to go to Object Properties. And I'm going to go to Color. And we're going to make this one black. Then I'm going to go to Style. And I'm going to increase that thickness. So I'm going to get a nice, thick function that's easy to see. So this is my original cubic function, x cubed minus 12x plus 4. Now what I'm going to do is I'm going to get the program to graph the derivative, and we're going to do it, there's a super easy way to do it, and we're going to do that at the end because I want you to see the creation of the graph from step 0 on. So what I'm going to do is get a point that will trace out along this graph, because remember, a derivative is the slope of the tangent line. So I need to somehow be able to get this program to graph the slopes. In order to get it to graph the slopes, I need to get it to kind of trace along this curve. So what I'm going to do is go put up what's called a slider. And I'm going to go right here. And it's going to name the slider A. That's fine. And it's going to go from -5 to 5, which is good on my graphing window, and we don't need any increment, so it looks like we can just hit OK for that, and that pops this slider. So it's not doing anything right now because I haven't really created it. I could put a point on here and call it A, but I'm going to in a moment. So what I'd like to be able to do is trace along the curve. So first thing I'm going to do is kind of outsmart it here. I'm going to say x equals a. And so what I'm telling the program to do is graph all the lines where x equals a. So when I hit return, because a is now at -2.3, you're going to see a vertical line pop up right here at -2.3. But remember, this is a slider. So I'm creating this vertical line sliding. Well, that's not what I want. I'd like the point on the curve to be able to slide. So next thing I do is I'm going to go grab my point tool here, and I'm going to put it right at the crosshairs, and you'll notice at the bottom it says function f and the line, and I want to click on that, and that's where I would like my point to be. So now you'll notice I've got a point labeled on that curve that's moving with my slider. But I'd like to get rid of that vertical line. I only created it so it could help me get that point. So I'm going to go grab my pointer tool if I don't have it grabbed already. I'm going to click on this line, control click or right click. And what I'm going to do is click this show object box and it'll take away that line. It's basically just hiding it. So now I've got what I would like. You see that point A kind of moving along the curve. I'm wondering if I can go make that point A in a color. It's hard to see it. So let's give that a whirl here too. Let's go to object properties. Let's make the color of that point, let's say bright pink. Should be a little there. Now it's a little easier to see it. So again, as I move the slider, point A is moving along this curve. And what the derivative is it's the slope of the tangent line at the point on the curve. So if I stop right here at the slider, the derivative of the curve right here would be the slope of the tangent line. Well, let's go create the tangent line there. So under my top menus up here, I have an option right here that says tangents. So I'm going to click on that. So I'm going to make the program make a tangent line to the curve at point A. So I click on that. You'll notice it changes this and it tells me what to do. It says in the yellow box, select a point or line and then the function. All right, can do. So I select the point and then the function and up pops my tangent line. And it'll move along. So I've kind of created this little tightrope walker thing here. Move it nice and slow so you can see what it's doing. Notice right here, the tangent line is horizontal. The slope of the tangent line is 0. So we'd say the derivative of the curve right here is 0. Let's go change the properties of that tangent line. So again, control click. Let's go object properties. Let's make it pretty. Maybe we'll do that in red. And let's make it thicker. And maybe we'll make it dashed. All right. So let's see what we've got going here. We now have a slider moving point A along the curve. The tangent line is going with it. Well, let's talk about the derivatives here. So notice point A right here down at the bottom. The tangent line is a steep, positive line. So its slope is going to be positive as well. Well, what's the slope going to be? Well, let's make the program tell us that as well. So if I go up here, I believe it's under this option. Yep. And it'll give me the slope. I just got to tell it to. So I hit slope and the little box will say select a line. Well, I want the slope of the tangent line. So now you'll notice it popped up a 43.47. It also, by the way, puts it over here. So the slope of the tangent line right at point A is 43-ish. Now watch it change. It's still positive, but it's less positive, less positive, less positive. Now right at the top here, you'll notice that the slope is 0. It says m equals 0. It says it right there too. It's just hard to see it. Now as I start traveling down the roller coaster, you'll notice those slopes are negative. They're negative all the way to here, and then I have a slope of 0 again, and then they're positive. So what I'd like to be able to do is have, sorry about that, is have the program plot a point that would represent the derivative. Well, the derivative is the slope, and I want to plot that slope as the y-coordinate of a point. And the x-coordinate would be, well, at point A, the slope here is 16, so I'd like there to be a dot at 16. Watch what I mean, just so you get the idea. I'm going to slide this over. Right here, at -2, whoopsie, trying to get it perfect. Well, at -2, the slope is 0, and what I'd like to get it to do is plot a point at -2, 0, so I could see a graph of the derivative. So if I go down to the bottom here and I create a point, and I'm going to call it P, and I'm going to say it equals, and I want it to plot the slopes of the tangent lines, the m's, at every point A. So A, comma, M. Hit return. Now you'll notice where that point got plotted, and that's because it says the slope is 1.23 at A. So as I move this along, you'll notice now P is below the x-axis because the slopes are negative. It's coming less negative, less negative, less negative. There, it's 0 again. So you'll notice that point P that's going along there would represent the derivatives everywhere. And if I go fast, you can see that looks kind of like a parabola. Well, could I get it to trace that? I can. I go and I hit Control on the P, and I just hit Trace. And now what will happen is, as I slide this, you can see the derivative being traced out. And it looks like a parabola. Now watch. Why is it that the derivative graph comes from up above here and is positive, and the original comes from down below or is negative? Remember, the derivative is the slopes, and the slope right here is very positive, and it gets less so as I travel up the roller coaster. It's getting less positive, less positive, less positive, less positive, 0, which is why my derivative graph hits the x-axis here. Now on this whole downward slide of the roller coaster, the tangent lines are negative. That's why my derivative graph falls below the x-axis here, because all the derivatives, the slopes of the tangent lines, would be negative. Now, I'm going to take that off of there. And I just hit undo and it took those trace dots off. And I'm also going to take this little triangular box off as well. Again, if I hit Control and if I just do that, it'll take that off. So back to here. Oh, don't want it to do that. I'm going to take that off. So now I could just enter f prime of x and hit return, and it'll graph exactly what those points we're tracing out. So again, let's go make this a dark blue line. Control click on it. Object properties, color, blue, style, very thick, and I'm good. So in black, I have my original function. It was a cubic function. In blue, I have the graph of the derivative, which is created by connecting all of those slope dots as I travel along this curve. And we're done. Now watch me go change the function. I'm going to put an easier one up here. So I'm going to go right here. I think it'll allow me to change it right in here. I'm going to clear that out. I'm going to do x squared. And again, to do the squaring, I click on this little symbol here, hit squared. Let's do -4. I'm going to hit return. Got a mess going here, but that's okay. I'm going to go to my axes and make them back to normal. A little practice. I just hit Control. I'm going to do x, y-axis for this parabola. It can just be 1 to 1. I'm going to zoom in. Practice a little bit. Let's zoom right in here. Actually zoom out. I'm going to click once, click twice. Looks good. All right, so let's see what we have here. On my slider, let's go back. My original was a parabola, right? And look at point A. Look at the red dotted line. It's a tangent line that's going downhill very steeply, so its slope is negative. That's why this blue line, which is the derivative, starts way down here because it's plotting the slopes. And the slopes are, as we move along, if you look at the M over there, the slopes are negative, but they're getting less and less and less negative. The slopes are still negative until I get right to the vertex, and that's where the slope is 0. And that's why my derivative graph is hitting at 0. So that's it. That's the end of this video.